Hello and welcome to this week's video lesson on patterns and relations where we'll focus on keeping equations balanced. Let's start by reviewing our learning and language goals for this lesson. Our learning goal for this lesson is to demonstrate and explain the meaning of the preservation of equality. And our language goal is to be able to talk about this concept using words like equality, equivalent, equation, and the preservation of equality. Okay, I want to model this equation, 2 plus 4 equals 3 times 2. And I can do that in many different ways. One of the most effective ways I find of modeling equations is using counters like these. Now, I'm not going to use these exact counters on this video. What I'll be using is circles on the screen to represent the counters. But if you have counters at home, then you can use them to help you model, or maybe you have some coins, or you can cut out circles of paper, you can draw counters, you can use Lego blocks. Really anything that is the same size and shape will work to help you model this, just like when we modeled our integers using integer tiles. Okay, so in this case, I'm going to use circles on the screen to represent counters to help me model this equation. So here's how I'm going to do it. For the 2 plus 4, I'm going to model it like this: 2 counters and 4 more counters, 2 plus 4. So we see how this represents 2 plus 4, which adds up to a sum of 6. Next, we can show 3 times 2 like this, as 3 groups of 2. And we see how this picture represents 3 times 2, which gives us a product of 6. We see that both sides equal 6, so we can say the equation is balanced. Now, let's say we want to subtract 4 from each side. So I'm starting with 6 on each side and subtracting 4. And you see with my equation written out in symbols or in the numbers, I have 6 minus 4 equals 6 minus 4. But let's model it with our counters. If we subtract 4 from each side now has 2 counters. Or we can imagine we add 2 to each side, and you can see that reflected in the numbers. And if I add 2 to each side now has 8 counters. Next, let's multiply each side by 2. Each side now has 12 counters. And if we divide each side into 2 equal groups, each group now has 3 counters. Whatever we did to one side of the equation, we did to the other side too. And each time the number of counters on both sides remained equal. So the equation remained balanced. When each side of the equation is changed in the same way, the values remain equal. This is called the preservation of equality. Now, the same is true if one side of the equation is an expression containing a variable. Let's model that out with a little bit of a different tool. Let's consider this equation using a variable. 6 equals 3t. In this case, 3t is our expression that uses the variable. T is the variable, and 3t means 3 times t. Now, I'm going to model this using number strips, and they're similar to fraction strips, but I find it's a really good way to help represent equations that have variables. So in this case, you can see in this picture, there's one blue strip that represents the value 6, and it's exactly the same length as those 3 strips end to end, which are labeled with t. So you can see here, 6 equals 3t, or 3 times t. Now let's see what happens when we do things to both sides of this equation. For instance, we can add the same number to each side. So 6 plus 1 equals 6t plus 1. And we see here what we did was in the model, we added a small green piece that represents 1. And if you measured it, you would find it is exactly 1/6 of the size of the blue strip that is labeled 6. So we have to be sure, if we're using number strips, that we have those proportions correct. All right, same equation, 6 equals 3t, but this time we're going to subtract 1 from each side. So what does that look like when we model it out with the number strips? Well, we start with our 6 equals 3t, and then we're subtracting 1 from each side. So our equation is 6 minus 1 equals 3t minus 1. We're doing the same thing to each side. And in our model, we have a dotted line that represents where we would cut if we were going to remove or subtract 1 from this equation. And you can see that the 1 that we're subtracting is the same exact size as the 1 that we added on before, which is the same as 1/6 of the full blue 6 strip. Okay, we can also multiply both sides by 2. So 2 times 6 equals 2 times 3t. And the way we model that is by showing 2 6s and 2 sets of 3t. So 2 times 6 equals 2 times 3t. I'm sure you could have predicted that I was going to move to division next after I did addition, subtraction, and multiplication. So here it is. How are we going to model 6 equals 3t when we divide both sides by 2? So 6 divided by 2 equals 3t divided by 2. And here's how we model that using number strips. All right, so we have our original 6 equals 3t, and we're using that dotted line again to indicate that we would cut this exactly in half and split them apart. That is how we divide by 2. And the most important thing is that both sides are still equal. Okay, when we do the same thing to each side of an equation, we produce what we call an equivalent form of the equation. So all of those things we did to our 6 equals 3t, 6 plus 1 equals 3t plus 1 when we added 1 to each side, 6 minus 1 equals 3t minus 1 when we subtracted 1 from each side, 2 times 6 equals 2 times 3t when we multiplied each side by 2, and 6 divided by 2 equals 3t divided by 2 when we divided each side by 2. All of these are equivalent forms of the equation 6 equals 3t. Okay, time to check for understanding. Let's consider the equations 12 equals 4s and 12 divided by 2 equals 4s divided by 2. Are these equations equivalent? Did you say yes? If so, give yourself a big pat on the back. You got the answer right. Since we did the same operation to both sides of the equation, divide by 2, they are equivalent. And we can say we have demonstrated the preservation of equality. Okay, let's work through a problem together here. I have an equation, 3n equals 12, and one part of this equation is an expression that includes a variable, 3n. Now, I have two things that I need to do to it. First is I need to write an equivalent form of the equation. And it kind of tells me how to do that in the question because it says apply the preservation of equality to write an equivalent form. And then I have to draw a diagram to show my understanding. So let's work through part 1 first. When I think back to earlier in this lesson, I remember that an equivalent form of an equation is just another equation that is still balanced, where I've applied the preservation of equality. So in other words, I've done an operation, an equal operation, the same operation to both sides of my equation. So for this, in order to write an equivalent form of 3n equals 12, I'm going to have to do an operation with a number, but I'll need to make sure I do the exact same operation to both sides. So I think I will divide by 2. Let's see what that looks like. All right, so if I start with 3n equals 12, and then I divide both sides by 2, I get 3n divided by 2 equals 12 divided by 2. What's my operation? Divide by 2. I did the same one to both sides, so I've created an equation that is an equivalent form of the original equation by applying the preservation of equality. In other words, I did the same exact operation to both sides, and I maintained or preserved that equality. Next step is to show this using diagrams. To do that, I'm going to use number strips, and I've just used the drawing tool in Google Slides to create my number strips. So I have my original equation, 3n equals 12. And what I did was I drew a long rectangle, which you can see here in green, and that represents my 12. And I made 3 smaller rectangles, each one exactly 1/3 of the length of my 12. And I lined them up end to end, labeled each one n to show that 3n equals 12. The 3 n's match up exactly with the same length as 12. So this diagram represents the equation 3n equals 12. And to show myself applying that operation of dividing by 2, what I'm going to do is I'm going to use a dotted line to show that I am dividing it in half. And I've put that dotted line exactly down the middle of the strips to show that I'm dividing by 2, which is creating 2 equal groups, and each side is still exactly the same. So I have demonstrated that equality. Remember, when each side of the equation is changed in the same way, the values remain equal. This is called the preservation of equality. Do you feel like you have a solid understanding of the preservation of equality? If not, go back and rewatch the video, but this time pause to model the examples with counters like these, coins, Lego bricks, paper strips, or any other concrete tool that helps you to understand better. And remember, you preserve equality when you do the same operation to both sides of an equation.